You are watching one of a series of videos giving an introduction to OrcaFlex. The first 4 of these videos, which we've called the fundamentals, are those that we would regard as prerequisites for looking at any of the other subsequent topics. If you are already familiar with these fundamentals, you may want to pick and choose the subsequent videos you watch based on your area of interest. If you're a complete beginner with OrcaFlex, I would strongly encourage you to watch the full series in order, as this will give you a good basic overview of the program, how to navigate it, and where to access and input data. It goes without saying that the quality of any OrcaFlex analysis is only as good as the quality of the input data, and that, of course, relies on the skill and experience of you, the user. These videos will help you to learn how to use OrcaFlex as one of your analysis tools, and I do hope that you find them educational and maybe even a little bit enjoyable too. This video will cover the basics of running a simulation. Having created a basic data file in the previous video, we'll now use this as the basis for running an analysis and looking at some results. First of all, we will open our previously created data file. If you don't have this data file, I would suggest working through the previous video first in order to create and save the model that we will use now. So now that we have the data file open, the first thing we can do is run a static analysis. This is done by clicking on the Calculate Statics button in the toolbar, or using the F9 shortcut key. The message box in the status bar reports the progress of the analysis. You can see this is almost instantaneous with this simple system. And when it's finished, the program state message in the center of the status bar changes from reset to statics complete. The statics calculation may be an end in itself. You may just be interested in the static equilibrium of a system, or it can be used to provide a stable starting configuration for a dynamic simulation, which we'll come on to later. You can choose to go straight to a dynamic simulation, but OrcaFlex will still perform a static calculation. This is an important step in order to avoid transients at the start of dynamics. Well, now that we're in the statics complete state, we can look at some results. So to do this, we need to click on the Results button on the toolbar. And this opens up the Select Results form. At the left side of the form is the list of available results types. If greyed out, these result types are not available with the model in its current state. In the center of the form are the model objects, including any additional selections necessary for a particular result, such as a reporting position or a line arc length. At the upper right are the time periods, including static state and whole simulation, amongst others. And finally, in the lower right are the available results variables. Depending on the object selected, this can be a very large list, so it's also possible to filter the list using the options to the right. First, as we have the line object selected, let's look at some static state results for this line. We have static result selected as the type. My riser is selected in the center, and we'll look at some results for the touchdown point, so we need to specify this point as the reporting position. Static state needs to be selected as the period, and we'll pick effective tension and curvature as 2 results to look at. Note before we move on that if you want to look at results for a specific position other than the ends or the touchdown point, you can specify 1 or more arc lengths or node numbers in these sections of the position table. Okay. When we close the window, we can see this gives us a single value in 2 separate tables for these results. Now it is possible to combine multiple static results into a single table. If we go through the same process again, selecting our first result and holding the Control key while selecting the next result, and then if we press Show Now, we have a third table showing both results in one. So I'll close the windows for the 2 separate results, which leaves us our combined static state results. We can also look at a result for the whole length of a line. rather than a single point, and this is called a range graph. So we need to select the range graph as the result type. Make sure our line is selected, and in this model that is the only option. We'll look at again the static state period for effective tension, and let's show that result now. So this has given us a graph now of, in this case, effective tension for the whole length of the line. We can also specify particular sections of the line. And with a range graph result like this, we can right-click on the graph and we can view the underlying data by selecting values. Alternatively, we can bypass the graph and back on the results form, and we can go straight to the data by clicking on values. Now at this point you might be looking at these results tables and thinking they look like spreadsheets. Well, they have been designed to easily integrate with Excel. For example, we can select some results in the table. We can go to the right-click menu, select Copy, and then go to Excel and Paste. We get that data from OrcaFlex. Or we can use the right-click menu and select Export to directly save an Excel, a CSV, or a TXT file. As mentioned before, there is no autosave feature in OrcaFlex, so now would be a good time to save the file again. We've already learned about the two file types for data files, DAT and YML. And now that we've run a static calculation, we're introduced to a third file type, .sim. If any form of calculation results, either statics or dynamics, are available, then a sim file will be saved. This is a binary file which includes the model data, the latest calculated state, and the log file which contains results of the dynamic simulation, if performed. As well as saving the sim file, we can also use the workspace facility again to save results windows, or, as in this case, a combination of results windows and 3D view. This can be very useful if you repeatedly want to access the same results for a model or series of models. So here we'll save a workspace and we'll call it results.wrk, and this will save the windows in the exact configuration that we have them on screen here. And we can remove all of the windows, and when we go and open that results workspace from the workspace menu, it will reinstate all of the windows exactly as they were before. And for a simulation file, we can also save a default workspace, which will open every time we open the simulation file, and this applies to both static and dynamic simulations. We can now move into Dynamics by clicking on the Run Dynamic Simulation button in the toolbar, or pressing the F10 key. As the simulation progresses, the status bar reports the current simulation time and the expected time to finish the analysis. Actually, with our very simple system, there isn't time for OrcaFlex to calculate the time to finish, and I've had to pause this view so that you can see the simulation progress in the status bar. The status bar then tells us that we're now at the Dynamics complete state, but you will see that we have a warning message. These warning messages provide important information which may need to be acted on, but they do not mean a failed simulation. In some cases it may be appropriate to ignore the warning if, say, it pertains to a part of the system that is not critical to the current analysis. However, the information given should always be reviewed and a judgment made, and there's usually helpful links to the documentation, as is the case with this warning about the treatment of compression in the line. We can click on the More Details button here, which opens up the help file to the relevant section. In our case, we do not need to worry about this warning at the moment, but we will come back to it in a later video. And if you've closed a warning and want to look at it again, you can go back to the message from the Calculation menu and click on the View Warnings option. Now that we've completed a dynamic simulation, we get to the interesting bit, running a replay. There are a number of options relating to replays which can be found in the Replay menu, as well as in the Replay section of the toolbar. First of all, we'll start the replay. As the replay progresses, an animated view of the simulation is shown in any of the open 3D views, and the current replay time is shown in the status bar. Negative time indicates the simulation is in the build-up period, the time in which the wave is built up from still water to full amplitude. When the end of the simulation is reached, the replay begins again. The view control keys and mouse can be used to modify the view while the replay is progressing, and the shaded graphics mode can also be enabled. And you'll see there's a slider in the toolbar, and this allows us to manually move to a particular point in time. We have other controls over the replay, which you'll see in the replay menu. Control F makes the replay faster, Shift Control F makes it slower. It's also possible to step through the replay one frame at a time using the Control A shortcut, or indeed backwards using Control B. And this can be particularly useful when diagnosing problems in a dynamic simulation. So, hitting Control F, you can see, is progressively making this replay faster. Shift Control F is then slowing it down again. And if I go to Control A, you can see the replay time in the status bar moving one frame at a time. And if we click on the Edit Replay Parameters button, you can see some other options, such as replaying a specific part of the simulation and also adjusting the replay speed. Having run a simulation, if you want to make a change to your model, you will find many of the options are greyed out. Take for example the line data form and the positions of the line ends or its length. To change parameters such as these, you'll first need to return the model to its reset state, and this is done by pressing the reset button in the toolbar or by using the F12 key. When this is pressed, you will see, if you haven't already done so, a prompt to save the model. Whether you choose to save the simulation or discard it if you don't need it, the model will then return to the reset state as indicated by the program state message in the status bar. You can now make the necessary changes and then rerun the simulation. Note that you can also reset a model partway through a dynamic simulation, for example if something has gone wrong but the model hasn't yet failed or completed dynamics. Moving on now, and as with the static simulation, we can also look at results for dynamics. The obvious difference is that the time period options become relevant. In statics, it was only static state results that we could view. If we take a look at a time history for effective tension of the riser hang-off, that is, end A of the line, we're presented with a graph showing the change in effective tension at that point over the time specified. In this case, the whole simulation. As highlighted earlier with the replay, there is a compressive wave issue with this model, which is confirmed by looking at the wide variation in tension at the hang-off, which cycles from positive to negative as each wave passes. We'll actually resolve that in a later video by introducing a lazy wave profile to the riser. As with the static state range graphs we looked at previously, we can use the pop-up menu to access the underlying values for the graph. Moving on to a range graph for the line, we'll look at the latest wave as our time period this time. Again, effective tension is the variable we'll look at. Again, we're presented with a graph, but now we have multiple lines plotted. These include the effective tension variation in terms of maximum, minimum and mean values for every node on the line over the latest wave, which is for this model the final 8 seconds of the simulation. You can call up a wide range of results parameters for both time history and range graph options. You can also look at detailed numerical results using the Summary Results, Statistics and Linked Statistics options. As well as viewing results, we can export them to Excel, as we saw earlier with the static state results. We can also directly print graphs, results and 3D views from the pop-up menu. Additionally, we can export a dynamic replay as a video file using the Export Video option from the 3D View pop-up menu. Note that this will only save the active view. Finally, we will save the simulation again. Both static and dynamic simulations are saved as sim files, so as soon as we click Save, the static simulation file previously saved will be overwritten. You can also see in the File menu a Save Data option, which can be used to recreate the DAT file if this has been deleted. We've now covered the basics of the OrcaFlex user interface, the objects, and how to create a model and run a simulation. The next video will look in more detail at the line object.